Are you feeling lucky today? Maybe you should. Think about it. Out of all the possible ways the universe could have turned out, we ended up in one that allows you, me, and everything around us to exist. The odds? Well, let's just say they're mind-bending. If the dark energy in our universe had been just a bit stronger, galaxies never would have formed. If it had been weaker, the whole universe might have collapsed before stars had the chance to light up the sky. And yet, here we are, breathing, thinking, and asking these kinds of wild questions. So, was it just luck? A cosmic fluke? Or is there something bigger at play? Like the idea that our universe is just one of countless others, and we just happen to be in the lucky one? Stick around, because this story is just getting started. The fine-tuning of our universe is, frankly, ridiculous. Let's get specific. The dark energy density in our universe is around 10 to the minus 9 joules per cubic meter. But according to quantum field theory, it should be between from 10 to the 56 up to 10 to the 120 times higher. Yes, you heard that right. That's a 1 followed by up to 120 zeros. Imagine if you were trying to balance a pencil on its tip, but on a trampoline during an earthquake. That's how unlikely this balance is. Steven Weinberg, Nobel Prize-winning physicist, calculated that for galaxies to even form, dark energy had to be lower than about 10 to the minus 7 joules per cubic meter. Our universe, almost perfectly just beneath that, like it's skimming the limit. If it had been even a fraction higher, we wouldn't be here wondering about it. No stars, no planets, nothing. And it's not just dark energy. The strength of gravity, the mass of the proton, even the charge of the electron, all these constants are precisely what they need to be for complex matter, chemistry, and eventually, life to happen. If the electromagnetic force were slightly stronger, atoms wouldn't form. If it were weaker, stars couldn't ignite. You can't help but wonder, right? How did the universe get all these dials turned to exactly the right settings? Go ahead, think about it for a second. Does this feel like pure chance to you? With odds like these, it's no surprise that some people look at the universe and think, this has to be the work of design. Maybe it's a god, or maybe an advanced alien civilization, something or someone who fine-tuned the settings of reality just so life could happen. This is what we call the intelligent design argument. It feels intuitive, doesn't it? When things line up too perfectly, our brains naturally look for an intentional hand behind it. But here's the thing. Science isn't satisfied with intuition alone. Scientists like Steven Weinberg, who actually didn't like the idea of invoking design, sought other explanations. Instead of a deliberate creator, they explored natural mechanisms. For example, the anthropic principle. Simply put, it suggests we observe the universe to be life-friendly, because if it weren't, we wouldn't be here to notice. It sounds like circular logic, but it actually helps frame the problem scientifically. And don't forget the quantum contribution here. Quantum fluctuations at the very birth of the universe might have nudged the cosmic settings in just the right way. No divine intervention required, just random chance playing out across a vast, possibly infinite set of possibilities. So, what do you think? Are we the result of an unimaginable stroke of luck, or is there a grand designer behind the curtain? Hold that thought, because things are about to get even weirder. Here's where the multiverse steps into the spotlight. Instead of assuming there's only one universe, ours, scientists like Brian Cox and Neil deGrasse Tyson suggests something far bigger, an endless collection of universes, each with its own set of physical laws. Think of it like an infinite cosmic lottery. If there are trillions upon trillions of universes, maybe even an infinite number, then even the most unlikely outcome, like a universe perfectly tuned for life, becomes not just possible, but inevitable. Steven Weinberg linked this to the anthropic principle back in 1987, arguing that we naturally find ourselves in a universe that allows life because those are the only universes where observers like us can exist. Smart, right? And it doesn't stop there. Quantum fluctuations, as described by quantum field theory, could be the random number generator behind these universes. Tiny, chaotic energy spikes in the early universe might have set each new bubble universe on its own course, with its own rules. Imagine blowing soap bubbles, but each one is an entire universe floating in a cosmic foam. Some bubbles pop immediately, some grow endlessly, and a rare few, like ours, land in the sweet spot for life. Crazy? Maybe. But remember, inflation theory already predicts that space is expanding exponentially, possibly forever, creating endless new pockets of reality. So, here's the question for you. If infinite universes exist, and we just happen to be in one that works, does that explain everything? Or does it just push the mystery a little further down the road? Let's unpack this, because the multiverse isn't just one idea, it's a whole family of theories. First up, eternal inflation. Brian Cox explains it like this. Right after the Big Bang, space expanded at an insane rate, doubling in size over and over in a fraction of a second. If inflation never completely stopped, it could still be bubbling off new universes all the time, each bubble with its own rules, its own constants, some dead and empty, others bursting with stars and galaxies. Then there's the many worlds interpretation of quantum mechanics. You've probably heard of Schrödinger's cat, right? Well, in this view, every time a quantum event happens, the universe splits. One universe for every possible outcome. According to physicists like Hugh Everett and supported by Brian Greene, this creates a constantly branching tree of realities. Right now, there could be another version of you watching this video or deciding to skip it. Don't forget the black hole theory. Some scientists, including Neil deGrasse Tyson, entertain the idea that black holes could be the birthplaces of new universes. When matter collapses into a black hole, it might pinch off from our cosmos entirely, budding a new universe inside. Primordial black holes, formed just fractions of a second after the Big Bang, could even be hidden gateways. And finally, Max Tegmark's classification. Level 1, regions beyond our cosmic horizon. Level 2, bubble universes from eternal inflation. Level 3, quantum mini-worlds. Level 4, the mathematical multiverse, where every mathematical structure exists as its own universe. So, with all these theories flying around, it's like a cosmic buffet. But here's the kicker. Which of these, if any, holds the key to explaining why we're here? Quantum fluctuations. This is where things get wild. At the very birth of the universe, space itself wasn't smooth and steady. It was jittery, restless, like boiling water. Physicists call this quantum foam, a term made famous by John Wheeler. In these tiny, chaotic moments, random energy spikes could warp space-time and kickstart entire universes. Brian Cox describes how, during inflation, these quantum fluctuations got stretched across cosmic scales. Imagine wrinkles in fabric being pulled until they span light years. These tiny energy blips became the seeds of galaxies, and maybe entirely new universes. Here's a crazy visual. Think about the Wilkinson Microwave Anisotropy Probe, WMAP, and Planck satellite missions. They mapped the cosmic microwave background, the leftover glow from the Big Bang, and found tiny temperature variations, about 1 part in 100,000. Those are the fingerprints of quantum fluctuations, frozen in time. Now, if you scale this up, those same fluctuations could set different bubble universes off in wildly different directions. One universe might get just the right balance of forces for life. Another could collapse seconds after birth. The randomness isn't a flaw, it's the feature. So, what do you think? Are we just the lucky result of quantum chaos riding the crest of a fluctuation that happened to go our way? So, why does the multiverse theory matter? Because it might be the best shot we have at explaining why our universe looks suspiciously perfect for life. Without it, we're stuck with either pure luck or the idea of intelligent design. The multiverse gives us a third option: inevitability through numbers. Take this. The observable universe holds around 350 billion galaxies, and each galaxy contains billions of stars. But if eternal inflation is correct, that's nothing. There could be an infinite number of universes, each with its own set of physical constants. In that case, a universe like ours is not special. It's statistically bound to happen somewhere. Even the constants of the standard model of particle physics, like the mass of the Higgs boson discovered at CERN in 2012, could vary from universe to universe. Brian Greene points out that in some versions of the multiverse, you'd find universes with entirely different chemistry, or even no chemistry at all. And it's not just academic curiosity. Understanding the multiverse could change how we think about everything from dark energy to the origins of space-time itself. It could explain why dark matter, which makes up about 27% of our universe, remains invisible yet so crucial. So, here's something to chew on. If the multiverse is real, it means reality is far bigger and stranger than anything we've imagined. And maybe, just maybe, it means our existence isn't a miracle or a mistake. It's simply the way the cosmic dice happen to roll in this corner of infinity. Of course, not everyone's sold on the multiverse. In fact, many scientists see it as skating on thin ice. The biggest issue? Evidence, or rather, the lack of it. Experiments like the Planck satellite, which scanned the cosmic microwave background with 3 times better resolution than WMAP, found no convincing signs of collisions with other universes. No warps, no gravitational tugs, nothing you'd expect if universes were bumping into each other. And that raises a tough question. If we can't test it, is it even science? Critics like George Ellis argue that without falsifiability, the ability to prove something wrong, the multiverse drifts dangerously close to philosophy, not physics. Even Nobel laureate Steven Weinberg admitted that if the multiverse exists, then finding explanations for why fundamental constants are what they are might be hopeless, because they'd just be random accidents of our bubble. There's also the risk of public misunderstanding. Some worry that promoting untestable theories might erode trust in science itself. After all, if everything is possible somewhere in the multiverse, does anything really matter? But let's flip it. Isn't it exciting that we're wrestling with questions this big? So, let me ask you, should we chase a theory even if we might never prove it, just because it helps us make... So, are we really here because of the multiverse? Honestly, it's still an open case. Right now, the multiverse gives us a tempting answer to the cosmic puzzle of existence. It helps explain why the dark energy density is 10 to the minus 9 joules per cubic meter instead of catastrophically higher, why galaxies formed about 1 billion years after the Big Bang, and why carbon, oxygen, and all the building blocks of life exist at all. If you imagine a near-infinite spread of universes, each with random settings, it's not surprising that at least one of them, ours, would hit the jackpot. Brian Cox and Neil deGrasse Tyson both point out that quantum fluctuations and inflation could naturally produce this multiverse landscape. No supernatural intervention required. But let's not kid ourselves. We don't have proof. No telescope has spotted another universe. No particle collider has smashed atoms hard enough to crack open another reality. Yet, as science digs deeper into dark matter, quantum mechanics, and the structure of space-time itself, we're getting closer to understanding if the multiverse is a real framework or just an elegant story. So, what do you think? Are we here because we got lucky in an infinite cosmic lottery? Or is there still something hidden behind the curtain waiting for us to discover? Either way, the mystery is far from over. Whether the multiverse is real or not, one thing is certain. The fact that we're here thinking about it is already extraordinary. Even if we never find direct proof, the journey itself is pushing science forward. Research at CERN is still hunting for particles that could hint at other realities. Dark matter detectors buried deep underground are scanning for the invisible scaffolding of our universe, and quantum physicists continue to explore the strange possibilities of quantum foam. Max Tegmark once said that if the universe is mathematical, then multiverses might be inevitable. And remember, theories that once sounded impossible, like black holes, eventually turned into confirmed realities. So who's to say what future discoveries await? Maybe we'll never see beyond our cosmic horizon. Maybe other universes are forever out of reach. But here's a thought. Does it really matter? We're part of this incredible cosmic story. And every time you look up at the night sky, you're seeing the result of a perfect balance of forces that allows life to exist. So, keep your curiosity alive. Keep asking the big questions. And as we do here at Wonderscope, let's keep exploring the wonders of our universe. And maybe, just maybe, the ones beyond it too.